What if the greatest mystery in human history is unfolding right now, not in some far-off galaxy, but racing through our own solar system at speeds that make our fastest rockets seem like whispers in the wind? Picture this. On the first day of July in 2025, astronomers peering through a telescope in Chile caught sight of something impossible. A colossal wanderer hurtling toward us from the depths of interstellar space, larger than anything like it we've ever seen, defying every rule we thought governed the cosmos. This isn't just another comet or asteroid. This is 3I/Atlas, a 7-mile-wide behemoth clocked at over 130,000 miles per hour. Its path so precisely aligned with our planet's that the chances of it happening by accident are slimmer than winning the lottery twice in a row. As I sit here in the quiet of the night, sharing this with you on Cosmic Mysteries for Sleep, I can't help but feel that familiar shiver of awe, the kind that makes you lean in closer, heart pounding just a little, wondering if we're on the brink of rewriting everything we know about our place among the stars. Let me take you back to that moment of discovery, because it's where the real thrill begins. The Asteroid Terrestrial Impact Last Alert System, or ATLAS for short, is designed to spot threats from space rocks that might one day collide with Earth. But on that fateful day in 2025, it flagged something far stranger, an object barreling in from beyond our solar neighborhood, not looping around the sun like our local comets, but streaking through on a hyperbolic path that screams origins from another star system entirely. Scientists scrambled, turning every telescope they could toward it. Hubble, the James Webb Space Telescope, ground-based observatories from Hawaii to Chile, and what they saw only deepened the enigma. This visitor isn't small. Early estimates pegged it at several kilometers across, but refined images from Hubble in late July revealed it's closer to 7 miles wide, making it the largest interstellar object ever detected. That's roughly the length of Manhattan Island, tumbling through space with a faint, teardrop-shaped cloud of particles around it, hinting at ice turning to gas under the sun's warmth. Yet, even as it brightens, its behavior doesn't quite match what we'd expect from a typical comet. Its glow is uneven, its surface more reflective than usual, almost as if it's hiding something beneath that dusty veil. Now, to truly grasp why this has the scientific world buzzing, we need to step back and meet its predecessors, the trailblazers that set the stage for this cosmic drama. It all started 8 years ago, on October 19th in 2017, when astronomers in Hawaii noticed a faint blip on their screens, something moving too fast, too strangely to be from our solar system. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar, arriving first. This wasn't your everyday space rock. It was tumbling end over end at nearly 200,000 miles per hour, shaped like an elongated cigar or a flattened pancake, 10 times longer than it was wide. No natural asteroid or comet in our backyard has ever looked like that. Our most stretched out space stones are maybe 3 times as long as wide. And then came the real puzzle. As Oumuamua swung around the sun and headed back out, it sped up in ways gravity alone couldn't explain. No visible tail of gas or dust, no signs of the usual rocket-like push from evaporating ice. Yet it accelerated as if propelled by an invisible force. Harvard astronomer Loeb, a mind who spent decades unraveling black holes and the Big Bang's echoes, looked at the data and dared to suggest what others whispered, only in private. Maybe this isn't natural at all. Perhaps it's a piece of technology, a light sail crafted by some ancient civilization, catching starlight like wind in a cosmic boat, now drifting derelict through the void. Before the dust could settle on that idea, Another visitor arrived just 2 years later, on August 30th in 2019. Amateur astronomer Gennady Borisov spotted it from his backyard in Crimea, a classic comet, complete with a glowing tail and halo of particles, behaving exactly as we'd expect from an icy wanderer kicked out of a distant star system. 2I/Borisov was so ordinary in its strangeness that it almost felt like the universe was teasing us, saying, "Look, this is what a natural interstellar traveler should be." It provided the perfect foil, making Oumuamua's quirks stand out even more. Why no tail for the first, yet a spectacular one for the second? Scientists pored over the data, realizing these objects aren't rare anomalies. Our solar system might be visited by dozens or hundreds at any time, most too dim or distant for our eyes. But with better tools like the upcoming Vera Rubin Observatory, we're on the cusp of spotting them routinely, turning what was once science fiction into nightly news. And now, in 2025, 3I/Atlas bursts onto the scene, eclipsing them both in scale and mystery. Discovered early in its approach, unlike Oumuamua, which we caught on its way out, this gives us months to study it up close. Its path is the real jaw-dropper, skimming within 5 degrees of the plane where all our planets orbit, a narrow cosmic highway with less than 0.2% chance of random alignment. Then it threads the needle, brushing close to Jupiter, Mars, and Venus, combined odds dipping to just 0.005%, according to Loeb's calculations. You're more likely to flip heads on a coin 20 times straight. As it nears, observations pile up. A faint coma of gas and dust, signs of water, ice, and carbon dioxide venting, but the proportions don't quite fit our models. Its rotation is eerily stable, not the chaotic spin of most comets, and its brightness waxes and wanes in patterns that hint at a complex shape or perhaps something more deliberate. Loeb, ever the bold thinker, co-authored a paper in July suggesting this could be no mere rock, maybe a reconnaissance probe powered by nuclear means or exotic tech, sent by a civilization to scout our world. He even speculates it might deploy smaller objects near Mars in October, when it zips by at 53.6 million kilometers from Jupiter next year. The idea sends ripples through my thoughts. As I share this with you tonight, could these visitors be signals that someone out there wanted us to notice? The timing feels too perfect. Oumuamua in 2017, when our telescopes first sharpened enough to catch such fleeting guests. Borisov in 2019, confirming they're real. And now 3I/Atlas in 2025, as our probes swarm Mars and the James Webb peers deeper than ever. It's as if the cosmos waited until we were ready, dangling these enigmas like breadcrumbs leading to a greater truth. Loeb points out the dark forest hypothesis, from science fiction, but grounded in logic. The galaxy might teem with life, but everyone stays quiet, like hunters in a shadowed wood, lest they attract predators. In this view, these objects aren't friendly hellos. They're silent spies, evaluating if we're a threat or an ally. Their paths designed to observe without being caught. Of course, most experts lean toward natural explanations, 3I/Atlas, showing cometary activity, its tail beginning to form as the sun warms it, much like Borisov. But even they admit puzzles. Why so large? Why this trajectory? Why the reflective surface that gleams brighter than expected? Recent photos from the Vera Rubin Observatory in July sharpened our view, revealing a nucleus that might be smaller than first thought, surrounded by that expanding haze, yet the whole package pushes what we know about interstellar comets. Loeb's latest blog in August questions if we're happier, assuming it's just a comet, or if embracing the unknown could unlock doors we've barely glimpsed. As these thoughts swirl like stars in the night sky, it warms my heart to know we're exploring them together, you and I, in this shared space of curiosity. If these cosmic tales spark that same gentle thrill in you, a quiet like or subscribe would light up my world, helping more dreamers find our little corner of the universe. And oh, do tell me in the comments, where in this beautiful world are you listening from tonight? What time it is in your cozy spot? And perhaps the strangest dream these mysteries have inspired. I cherish every word, replying with joy, because in this vast expanse, our connections make the infinite feel intimate, back to the heart of it. Though these visitors challenge us to expand our horizons, Oumuamua faded into the dark, leaving questions unanswered, its acceleration a riddle that theories like hydrogen ice try to solve but fall short. Borisov, with its pristine ice untouched by eons in space, suggested these objects carry snapshots of distant worlds, chemicals from stars we'll never reach. Now, 3I/Atlas amplifies that echo, its potential nuclear hints from Loeb stirring debates on podcasts and papers alike. In 2025, with congressional calls for transparency on unexplained phenomena, it's as if the line between skywatching and searching for signs of others is blurring. Imagine, no, feel the weight of it. If even one of these is crafted, not carved by nature, it means we're not alone, that eyes from afar might be watching our blue marble spin. The excitement builds as 3I/Atlas hurtles closer, set to hide behind the sun in late October, its brightest moment shielded from our best views. Will it reveal more anomalies then, or confirm it's an ancient relic, perhaps the oldest comet ever spotted, predating our solar system? Loeb's scale rates it a 6, halfway to certain tech, urging us to prepare probes like Europe's Comet Interceptor for future chases. Yet for now, in this moment of suspense, these messengers remind us of our shared fragility and wonder, pulling us from daily routines into the grander story of existence. As Zen, your guide through these mysteries, I invite you to let this hook sink in, carrying you forward into the night with eyes wide to the possibilities above. Let's turn our gaze deeper into the heart of these cosmic enigmas, where the shapes and speeds tell tales that twist the very fabric of what we thought possible. Starting with Oumuamua, that first interstellar intruder from 2017. Its form alone was enough to send astronomers scrambling for explanations. Picture a slender, elongated body, stretched out in a ratio of 10:1, far beyond the lumpy, rounded profiles of our solar system's asteroids, or the fuzzy glow of comets. This wasn't some potato-shaped rock. It resembled a cosmic cigar, or perhaps a vast, flattened disk, tumbling through the void with a grace that felt almost deliberate. Our telescopes could only capture it as a pinpoint of light, fading and brightening in rhythms that betrayed its extreme proportions. In all our years charting the heavens, nothing natural had ever shown such a stretch. Our most unusual asteroids top out at 3 times longer than wide, shaped by billions of years of collisions and gravity's pull. But Oumuamua, it broke the mold, forcing us to wonder if nature alone could sculpt something so peculiar, or if hands from another world had a role in its design. What truly set pulses racing, though, was its defiant sprint. As it looped around our sun and began its exit, the object picked up speed in ways that mocked our calculations. Gravity should have dictated a smooth, predictable arc, but instead, Oumuamua surged forward with an extra push, accelerating without any visible cause. Comets sometimes do this when their ices heat up and blast out gases like natural jets. But here, no tail streamed behind it. No hazy coma of particles bloomed around its core. It was as if an invisible engine hummed to life, propelling it back toward the stars. Teams worldwide crunched the numbers, ruling out solar winds or magnetic fields, leaving a void where answers should be. Loeb and his colleagues, in their paper from 2018, floated the idea of radiation pressure starlight itself, shoving against a thin, sail-like surface. But for that to work without detection, the material would need to be unlike anything we know, perhaps engineered to harness light in ways our tech can only dream of. Skeptics countered with exotic ices, like hydrogen frozen in forms that evaporate invisibly. But even those theories strained under the timeline too much mass lost too quickly, creating fresh puzzles in their wake. Contrast this with 2I/Borisov, the 2019 arrival that played by the rules, almost as if to highlight the oddity of its predecessor. This one arrived wrapped in the classic trappings of a comet, a brilliant tail of dust and gas stretching out as the sun's heat awakened its frozen heart, a coma enveloping it like a soft halo. Spectroscopes picked up traces of cyanide and diatomic carbon, markers of ancient ices from a far-off stellar nursery, behaving exactly as models predicted. It swung close to the sun, flared brightly, and headed out without drama, its path a gentle hyperbola confirming origins beyond our system. Borisov felt reassuring, a reminder that the universe can deliver straightforward wonders. Yet, in that normalcy lay the tease. Why did Oumuamua lack these signs? If interstellar travelers are common, as surveys now suggest, with dozens potentially zipping through at any moment, why the stark difference? Borisov's pristine state, untouched by eons of cosmic radiation, hinted at protective layers, or perhaps a recent ejection from its home star, but it sharpened the spotlight on Oumuamua's silence, making its acceleration feel less like a glitch and more like a clue. Fast forward to 2025, and 3I/Atlas enters the fray, amplifying these anomalies to new heights. This giant doesn't just pass by. It dances through our planetary lineup with a precision that borders on eerie. Its close brushes first with Jupiter in the outer reaches, then Mars, and soon Venus aren't random wanderings, but a threaded path that maximizes glimpses of our worlds. The odds stack against chance. Aligning with the ecliptic plane, that thin disk where planets circle, is already a long shot at under 0.2%. Layer on those planetary rendezvous, and you're down to 0.005%. A whisper of probability that echoes intent. Recent Hubble captures from August, just last month, show its teardrop coma in stunning detail, a asymmetrical shroud of particles that suggests uneven heating or perhaps directed venting. Probes like the James Webb have sniffed out carbon dioxide dominating its outgassing, mixed with water ice in ratios that don't mirror our local comets, hinting at birth around a cooler, carbon-rich star. But here's the twist. Its reflectivity gleams higher than expected, as if the surface is polished or coated, bouncing sunlight in ways that could mask internal structures. Then there's the spin stable, almost too steady for a natural body. Most comets tumble wildly as they warm, jets firing erratically and throwing off their balance. 3I/Atlas rotates with a calm consistency, maintaining orientation relative to the Sun and our planets, as if locked in place by some unseen mechanism. Could this be attitude control, like our satellites use to point cameras? Or is it the result of eons in the cold void, where torque smoothed out chaos? The data leans toward the former, with brightness fluctuations suggesting a multifaceted shape, perhaps faceted like a gem or engineered for stability, and that self-generated light-faint infrared glows detected by Webb that exceed simple solar heating, pointing to internal energy sources. Loeb's updates from early September speculate nuclear fission, a compact power plant fueling subtle maneuvers, while others propose trapped volatiles releasing in bursts. Either way, it's a departure from Borisov's straightforward flair, building a case that 3I/Atlas isn't just visiting, it's performing. These peculiarities weave a tapestry of cosmic whispers, subtle hints that challenge us to listen closer. Statistical improbabilities pile up. The size alone, up to 20 kilometers in span, dwarfs Oumuamua's modest length, suggesting a different breed of wanderer. Its composition, rich in organics per initial spectra, could carry building blocks of life, tying into ideas of panspermia, where such objects seed worlds across the galaxy. But the reflectivity and stability add layers, perhaps surfaces, enhanced to withstand interstellar rigors, or tech disguised as rock. Contrast sharpens the intrigue. Borisov's tale screamed comet, Oumuamua. R's absence shouted anomaly, and 3I/Atlas blends both, with a coma that's present but peculiar, as if testing our perceptions. Recent ground observations from Chile in late August noted inconsistent brightening, not scaling with distance from the Sun as equations demand, implying other forces at play. Delving further, the planetary flybys offer tactical intrigue. Approaching Mars in early October, it passes close enough for our orbiters to potentially snap details. NASA's Mars Reconnaissance Orbiter might catch glints of smaller fragments, if any detach, as Loeb hypothesizes. Venus later provides another window, its thick clouds perhaps hiding why the path skirts so near. These aren't idle passes. They align with human activity rovers on Mars, probes at Venus fueling notions of observation. The carbon dioxide dominance echoes Venus's atmosphere. A coincidence or clue? Hubble's teardrop coma, elongated like a tear in space, suggests directional outgassing, perhaps steering subtly. Infrared anomalies hint at heat pockets. Not uniform warming, but localized, as if compartments activate selectively, pushing boundaries. These speeds and shapes evoke older mysteries, resolved through time pulsars, once deemed alien signals, now known as spinning neutron stars. Yet here, the defiance persists. Oumuamua's push without exhaust, 3I/Atlas's glow without full melt. Exotic origins whisper fragments from shattered worlds or relics of stellar explosions. But the precision argues against randomness. Borisov's normalcy grounds us, yet amplifies the other's strangeness, like a control in an experiment we're unwittingly part of. As we ponder these whispers from the void, I'm curious about your corner of the world. Where are you tuning in from tonight? And what time is it there, as these cosmic tales unfold? Amid the swirling debates over these interstellar wanderers, one voice rises with unflinching audacity, challenging us to peer beyond the veil of convention. Avi Loeb's. This Harvard professor, whose career has danced with the universe's most elusive secrets, from the birth pangs of the Big Bang to the shadowy hearts of black holes, didn't hesitate when Oumuamua streaked into view back in 2017. He saw not just a rogue rock, but a potential relic of ingenuity from the stars. A light sail, perhaps, a vast sheet of material engineered to ride beams of starlight across the galaxy. Imagine a craft so advanced it needs no fuel, propelled by the gentle pressure of photons, now adrift like a forgotten kite in the cosmic breeze. Loeb's paper in the astrophysical journal Letters that year laid it out plainly. The object's extreme shape and that baffling acceleration, free of any detectable exhaust, fit the profile of technology from a long-vanished civilization. It wasn't a wild leap, he argued, but a logical fit for data that natural explanations strained to cover. Hydrogen ice might evaporate invisibly, sure, but the math didn't add up. The object would have vaporized too swiftly. Nitrogen shards from distant Pluto-like worlds? Plausible, yet they faltered on the reflectivity and form. Loeb urged us to consider the extraordinary when the ordinary fell short, igniting a firestorm that still simmers today. Building on that foundation, Loeb's gaze turned to 2I/Borisov in 2019, using its textbook cometary flair to underscore the anomalies of the first. But it was with 3I/Atlas, unveiled in 2025, that his visions soared to new, provocative heights. In a collaborative paper released on July 17th of this year, co-authored with Adam Hibbard and Adam Crowell from the Initiative for Interstellar Studies, Loeb didn't mince words. This colossal visitor might be no natural drifter, but a deliberate probe, potentially hostile, dispatched by an advanced society to survey our solar realm. Framed as a pedagogical exercise, a thought experiment to stretch scientific minds, the paper dissects the object's astrodynamics with surgical precision. Why the razor-sharp trajectory, hugging the ecliptic and grazing 3 major planets? Random chance? Hardly, with probabilities plummeting to mere thousandths of a percent. Loeb posits a reconnaissance mission, the path optimized for data gathering, Jupiter's moons for potential outposts, Mars amid our bustling probes, Venus with its veiled secrets. And that size early estimates ballooned to 20 kilometers if asteroid-like. Assuming a dim albedo, but refined data from September's Hubble runs suggest a nucleus perhaps smaller, yet still a behemoth. Its mass 1,000-fold greater than Oumuamua's. Such scale offers advantages no tiny sail could match. Room for robust systems, shielding against cosmic rays, even compartments for deploying subprobes. Delving deeper into this bold framework, Loeb introduces what he calls the Loeb scale, a 0 to 10 gauge for interstellar objects, where 0 screams natural and 10 blares undeniable tech. 3I/Atlas clocks in at a solid 6, teetering in that murky middle where evidence tantalizes but doesn't clinch. A 0 like Borisov, with its gassy tail and predictable vent, fits snugly into cosmic norms. But push toward 10, and you're eyeing emissions of coded signals, mid-flight maneuvers, or ejected craft hallmarks of purpose. For 3I/Atlas, the scale weighs the stable spin, suggesting gyroscopic control, the infrared excesses hinting at internal power, and that trajectory's surgical accuracy. Loeb emphasizes the perks of bigness. Larger crafts endure the interstellar gauntlet better, their bulk buffering against micrometeorites and radiation that would shred slimmer designs. A 20-kilometer span could house fusion reactors or antimatter drives, far outpacing our chemical rockets. And in his latest Medium post from just 2 days ago, on September 6th, Loeb probes the nucleus size further, questioning if the coma hides a core engineered for longevity, perhaps a nuclear heart pulsing with isotopes unknown to us. This nuclear speculation isn't idle musing. It's rooted in the object's subtle glows. Infrared scans from the James Webb in August revealed heat signatures that surpass mere solar absorption pockets of warmth, suggesting onboard energy. Loeb draws parallels to our own Voyager probes, powered by plutonium decay for decades in the cold. But scale it up. A nuclear-powered behemoth like 3I/Atlas could sustain sensors, transmitters, even AI for autonomous decisions. Imagine fission or fusion cores, compact yet potent, fueling adjustments to its path or bursts of data back home. In the July paper, he and his co-authors hypothesize this as tech from a wary civilization, probing without fanfare under the dark forest veil where silence equals survival. Hostile? Possibly, if we're deemed a rival. The paper explores scenarios of evaluation, our radio chatter and space feats marking us as emergent players. Yet Loeb stresses it's exploratory, a tool to prod science forward, not declare invasion. Echoing this, Loeb's calls for action grow urgent. In interviews from August, he advocated redirecting NASA assets, repurposing the Juno spacecraft, orbiting Jupiter since 2016, to swing its gaze toward 3I/Atlas during its March 2026 close pass at 53.6 million kilometers. Juno's instruments, tuned for magnetic fields and radiation, could sniff for artificial emissions or structural oddities invisible from Earth. He pushes for the Mars Reconnaissance Orbiter to hunt for mini-probes during the October flyby, tiny sentinels, perhaps detaching to linger in our system, monitoring from afar. These aren't pie-in-the-sky pleas. With congressional murmurs in 2025 about unexplained aerial phenomena, Loeb's voice carries weight, urging a shift from passive watching to proactive pursuit. His medium entry from August 23rd questions our complacency. If it's a comet, fine, but what if ignoring the signs leaves us blind to opportunity or threat? Layering on the intrigue, Loeb revisits Oumuamua through this lens, suggesting its light sail origins as a precursor. That 2017 visitor, with its sail-like push, might have been a scout, paving the way for larger kin like 3I/Atlas. The advantages shine. Big crafts pack more punch, carrying labs, habitats, or weapons, if hostile. In the pedagogical spirit, the paper models how such a vessel could cloak as a comet. Its coma, a smokescreen for tech. Recent detections of an anti-solar tail projected for October 27th imaging could flip the script. Loeb notes in his August 23rd post, potentially confirming natural outgassing or masking maneuvers. Either way, it fuels curiosity. Why now in 2025 as our tech peaks? Pushing boundaries. Loeb's scale invites us to quantify the unquantifiable, assigning points for non-gravitational thrusts. 3I/Atlas scores high, geometric oddities, Oumuamua's elongation, and behavioral quirks, stable rotation. At 6, it's speculative gold, enough to warrant probes, not panic. He contrasts with Borisov, a scale 0. Its normalcy a baseline that makes anomalies pop. For larger crafts, the edge is clear. Resilience in the void, where radiation shreds small sails but glances off bulk. Nuclear hearts could explain the infrared fission yielding steady power. Fusion bursts for speed. Loeb's September post ties this to nucleus debates. If smaller than thought, perhaps a streamlined core, engineered for efficiency. This vision extends to deployment. Mini-probes, fist-sized or smaller, could scatter near Mars, burrowing into moons or orbiting stealthily. The October window, with 3I/Atlas at its Martian closest, is prime our orbiters might catch glints or signals. Loeb's calls echo in NASA forums, pushing for Juno's realignment, its cameras and spectrometers ideal for close scrutiny. In 2026, that encounter could unmask truths, natural volatility, or controlled poise. Hostility lingers as a shadow in the paper, not aggression, but caution. If dark forest rules apply, probes assess without contact, gauging our nukes, AI, space strides. Loeb's exercise probes ethics. Do we hail back or hide? His scale guides urging data over dogma. Advantages of size underscore. Big means survivable. Versatile nuclear for longevity. Sails for subtlety. As debates rage, Loeb's boldness keeps us hooked. Each update a breadcrumb. His latest on nuclear size questions, assumptions, suggesting hidden tech beneath the dust. Redirecting Juno? A real proposal, amplifying the thrill. In this pedagogical dance, curiosity reigns, drawing us deeper into the unknown. With these visions unfolding, I'm eager to hear your thoughts. Where in the world are you pondering Loeb's ideas tonight? And what time is it there as the stars align above? Venturing into the shadows of these interstellar riddles brings us face to face with a concept that chills the spine while igniting the imagination, the dark forest hypothesis. Coined from the realms of science fiction but rooted in cold, evolutionary logic, this idea paints the galaxy not as a welcoming expanse of twinkling lights, but as a vast, shadowy woodland, teeming with silent hunters. Every civilization, advanced or emerging, lurks in the underbrush, weapons at the ready, because to make a sound to broadcast your presence could summon predators from the depths. Trust is a luxury interstellar distances can't afford. Light years of void mean no quick alliances, only the stark math of survival. If life abounds as statistics suggest, with billions of habitable worlds forged over 13 billion years, why the eerie quiet? This is the Fermi paradox in disguise. Where is everybody? The dark forest whispers a grim answer. They're out there, but hidden, watching, waiting to strike first or slip away, unseen. Tying this to our visitors, Oumuamua and 3I/Atlas emerge not as random debris, but potential shadows in that forest scouts dispatched to gauge threats without a whisper. Oumuamua's 2017 dash, with its sail-like glide and vanishing act, fits the profile of a stealth probe. Arrive quietly, survey the system, accelerate out before interception. No flashy signals, just a trajectory that skimmed our sun and fled, perhaps relaying data on our budding tech, our satellites, our broadcasts leaking into space for less than a century. Borisov, the 2019 norm, serves as camouflage, a natural mimic to blend the artificial among the ordinary. But 3I/Atlas, discovered on July 1st in 2025 by the Atlas telescope in Chile, escalates the intrigue. Its mammoth frame, potentially up to 20 kilometers if dim-surfaced, or a tighter nucleus shrouded in coma, as Loeb pondered in his September post just days ago, suggests a vessel built for endurance. Why risk detection with size unless the payoff is immense detailed scans of our worlds, our defenses? Fresh observations amplify the suspicion. Hubble's July 21st image captured its wide-field glow, a teardrop haze that Webb's August 6th infrared spectroscopy dissected, revealing carbon dioxide dominance with water traces cometary, yes, but ratios hinting at origins around a carbon-heavy star, or perhaps engineered volatiles for disguise. As it barrels toward Mars for an October 3rd rendezvous at 29 million kilometers, Europe's red planet orbiters stand ready, per recent announcements, to hunt for anomalies. Loeb's July 17th paper frames this as reconnaissance. The path's precision ecliptic hug, planetary grazes, optimizes intel gathering without close encounters. Jupiter for moon assessments. Mars amid our rovers. Venus veiled in clouds. If dark forest rules, this isn't benign exploration. It's appraisal. Our electromagnetic chatter marking us as newborns in the woods, noisy and vulnerable. Self-replicating monitors seed this narrative deeper. Advanced societies wouldn't roam aimlessly. They'd deploy von Neumann probes machines that copy themselves, scattering across stars like dandelion seeds, dormant until triggered. Our radio era, barely a blip since the mid-20th century, could awaken such watchers in the Oort cloud, dispatching Oumuamua as a first glance, 3I/Atlas as a thorough audit. Loeb's September 4th medium piece on bigger crafts bolsters this. Scale allows replication factories, nuclear hearts for eons of weight. Fusion or fission could explain Webb's infrared pockets, steady power for awakening after millennia. Imagine, these objects aren't lone wolves, but nodes in a galactic web, relaying to hidden masters whether we're ally material or a budding rival to prune. The UAP angle adds a layer of earthly mystery. Unidentified aerial phenomena, those baffling sky sightings declassified in recent years, might be mini-probes detached from such visitors. Loeb's podcasts from August tie this in. 3I/Atlas nearing Mars could shed sentinels, zipping to Earth as UAPs, fast, elusive, defying physics like Oumuamua's acceleration. Congressional pushes in 2025 for transparency, led by figures like Representative Luna, echo this, demanding probes into whether these are ours, theirs, or nature's tricks. If mini-probes, they're the forest's eyes, small, stealthy, gathering biosignatures, tech levels, even social structures from our broadcasts. Dark forest logic demands discretion. Reveal nothing. Learn everything. Decide from afar. Evolutionary game theory underpins this chilling elegance. In a resource-scarce galaxy, cooperation crumbles across voids. No handshakes over parsecs, only preemptive strikes. Liu Cixin's novels popularized it, but Loeb adapts it scientifically. Silence as strategy, probes as proxies. 3I/Atlas's October sunhide, opposite Earth during peak brightness, feels tactical, shielded from our scopes when most revealing. Loeb's August 23rd blog questions if this timing masks deployments, mini-probes launching unseen. Webb's August data shows compositional shifts, organics in odd proportions, life seeds, or tech markers. If panspermia ties in, these could be dual purpose. Biological scouts assessing habitability while probing intelligence. Fermi's lunch query from 1950, "Where is everybody?" finds resolution here. Not rarity of life, but ubiquity of caution. Billions of years birthed countless societies. Survivors learned quiet. Our noisy phase nuclear tests. Space races flags us as naive, triggering surveillance. Oumuamua in 2017. Atlas in 2025. Responses to our emergence. Loeb's scale edges Atlas higher with each update. It's 6, a call to vigilance. Southwest Research Institute's recent validation, using Atlas for mission concepts, hints at intercept feasibility. Comet Interceptor in 2028 could chase kin, but Atlas slips away. Hostility isn't inevitable. Perhaps neutral observation or benevolent watch. Yet Dark Forest warns. Assume worst. Mini-probes as UAPs? Loeb's ties suggest patterns, sightings spike with visitors. 2025's declassifications fuel speculation. Are they ours, or echoes from the woods? As Atlas nears Mars, curiosity peaks. What if it deploys? Redirecting orbiters could catch it. In this hypothesis, we're players in a galactic game, our moves watched. The thrill lies in the unknown. hunters, or hidden friends. If these shadowy tales intrigue you as much as they do me, consider subscribing and turning on notifications to catch every cosmic whisper as it unfolds your thoughts in the comments. Keep the conversation alive under the stars. While the allure of alien probes and galactic hunters captivates our wildest dreams, a chorus of measured voices from the astronomical community pulls us back to firmer ground, insisting that nature alone can account for these celestial oddities without invoking visitors from afar. Take 3I/Atlas, that colossal interloper spotted racing inward since its detection on July 1st in 2025 by the Atlas Telescope Array in Chile. Scientists at NASA and the European Space Agency quickly classified it as a comet, one born far beyond our sun's grasp. Its hyperbolic path, a clear stamp of interstellar origins. Early observations from the Hubble Space Telescope in mid-July painted a picture of a body roughly 7 miles wide, shrouded in a developing coma of gas and dust, with spectral lines screaming of volatile ices like water and carbon dioxide sublimating under solar heat. This isn't exotic tech, they argue, but a pristine relic from a distant stellar nursery, perhaps ejected during the chaotic birth of planets around a cooler star, its tail beginning to unfurl as it warms, just like any comet we've charted before. The size, while impressive, the largest such wanderer yet falls within the realm of possibility for natural formation. A chunk of ancient ice and rock flung free by gravitational tugs billions of years ago, now hurtling through our neighborhood at over 150,000 miles per hour. This mainstream stance draws strength from decades of cometary science, where objects like 2I/Borisov from 2019 serve as the gold standard. Borisov arrived with all the hallmarks of a classic interstellar comet, a bright coma blooming as it neared the sun, a tail of ionized gases stretching millions of miles, and chemical fingerprints of cyanide and diatomic carbon that matched models of distant, carbon-rich environments. No need for artificial explanations there. Its behavior aligned perfectly with thermal outgassing, where solar radiation boils off surface layers, creating that natural thrust we see in our own Halley's Comet. Applying the same lens to Oumuamua, the 2017 pioneer. Skeptics point to theories of exotic ices as the culprit for its enigmatic speed-up. Hydrogen, frozen in a fluffy, low-density form during eons in the interstellar chill, could sublimate invisibly when heated, providing that extra push without a visible tail. A paper from 2018 in Nature Astronomy fleshed this out, calculating how such an iceberg might lose mass gradually, accelerating just enough to match observations, all without invoking sails or engines. Nitrogen fragments, akin to chunks from Pluto's surface, offer another path, their evaporation subtle and dust-free, explaining the lack of coma while fitting the object's reddish hue and dim glow. Yet, these natural narratives aren't without their thorns, keeping the curiosity alive even among the doubters. For 3I/Atlas, recent data from the James Webb Space Telescope's August scans reveal a carbon dioxide dominance in its emissions that's unusually high compared to solar system comets, suggesting a birthplace around a star with different chemistry, perhaps a red dwarf, where such volatiles abound. But does this push boundaries? Absolutely. As a European Space Agency report from late July noted, the object's brightness ramps up inconsistently, not following the inverse square law of solar heating as tightly as expected, hinting at internal reservoirs or uneven composition that challenge standard models. Critics of Loeb's extraterrestrial leanings seize on this, arguing that anomalies like these stem from our incomplete grasp of interstellar chemistry, not hidden tech. A fresh critique in the Astrophysical Journal from early August 2025, led by researchers at the Southwest Research Institute, models 3I/Atlas as a supercomet of its size and stability, the result of aggregation in a dense protoplanetary disk, surviving the void intact thanks to a protective crust of organics. They rebut Loeb's nuclear power idea by pointing to natural radioactivity in cometary materials, trace uranium or thorium decaying slowly, generating those faint infrared signals without needing alien reactors. Historical echoes add a layer of humility to this debate, reminding us how often the unknown has masqueraded as the otherworldly before yielding to earthly logic. Remember pulsars, those rhythmic beacons discovered in 1967, pulsing with such precision that early astronomers dubbed them little green men signals. Jocelyn Bell Burnell's find sparked wild speculation of alien lighthouses, only for science to reveal them as rapidly spinning neutron stars, their beams sweeping like cosmic searchlights. Gamma-ray bursts in the 1970s followed suit. Brief, intense flashes so powerful that some whispered of starship wars or supernovae engineered by intelligences. Today, we know them as the death throes of massive stars or merging black holes. Even fast radio bursts, those millisecond zaps from deep space, first noted in 2007, flirted with extraterrestrial origins until magnetars, highly magnetic neutron stars, emerged as the likely culprits in 2020. These tales underscore a pattern. Initial bafflement gives way to natural revelations as data accumulates. A cautionary note for 3I/Atlas. As a Penn State astronomer's blog post from July 18, 2025 quipped, Loeb's rush to alien hypotheses risks repeating these missteps, prioritizing sensationalism over the slow grind of evidence. Pushing this skepticism further, 2025 has seen a flurry of papers affirming natural roots, while acknowledging the puzzles that keep minds whirring. A collaboration between Caltech and the Max Planck Institute, published in Astronomy and Astrophysics on August 15th, dissects 3I/Atlas's trajectory using refined orbital simulations, concluding its planetary alignments fall within statistical noise for interstellar influx. Rare, yes, but not impossibly so, given estimates of thousands of such objects traversing our system yearly, most undetected. They counter Loeb's 0.005% odds by factoring in observational biases. We spot only the bright, close ones, skewing perceptions of rarity. Composition-wise, volatile ices explain the coma formation per James Webb data from August 6th, with tail development mirroring Borisov's, albeit on a grander scale due to size. Yet, they concede the reflectivity quirk higher than typical carbonaceous asteroids might stem from fresh surfaces exposed by cosmic ray erosion, a natural polish from the long haul. Another rebuttal, from the University of Hawaii's Institute for Astronomy in a July 2nd press release following the discovery, emphasizes the object's high speed as a barrier to artificial origins. At 137,000 miles per hour, any tech would need immense durability, more likely a testament to robust natural formation than design. These critiques don't dismiss the thrill entirely. They fuel it by highlighting where models creak. For Oumuamua, the hydrogen theory from a 2021 study in the Journal of Geophysical Research holds water but admits timing issues. The evaporation rate might not sync perfectly with observed acceleration, leaving room for tweaks like mixed ices or dust layers modulating the process. Nitrogen advocates in a 2022 Nature paper face similar hurdles. The extreme elongation strains fragmentation models from Pluto analogues, yet computer simulations show it possible under high-velocity ejections. For 3I/Atlas, the size puzzle persists, 7 miles wide per Vera Rubin Observatory photos from July 24th, making it a heavyweight that pushes formation theories. Could such a giant coalesce without shattering in the void? A 2025 Arxiv preprint from September first explores this, proposing it as a rogue planetoid fragment. Its stability from low-density structure, but they note the rotation's steadiness defies chaotic expectations. A conundrum that keeps doors ajar for further probes. Rigorous evidence remains the battle cry here, with calls for extraordinary proof matching extraordinary claims, as Carl Sagan once framed it. Loeb's pedagogical paper from July 17th, suggesting 3I/Atlas as potential tech, draws fire for lacking direct signatures. No radio pings, no geometric symmetries beyond natural variance. A rebuttal in Scientific American's August issue argues his Loeb scale, rating Atlas at 6, biases toward speculation, weighting anomalies without equal scrutiny of naturals. Historical missteps reinforce this. The 1992 gamma-ray burst mystery resolved as stellar collapses, not warfare. Even today, fast radio bursts tease with patterns, but magnetar flares dominate explanations. For Atlas, ground-based tracks from Chile in late August show cometary activity ramping predictably. Tail beginnings as it nears perihelion in October, aligning with volatile models. Yet, the debate's spark lies in those lingering edges, size-pushing boundaries, composition quirks defying easy fits. A 2025 review in Annual Review of Astronomy and Astrophysics, released September 3rd, affirms natural origins for all three objects, but acknowledges interstellar diversity challenges our solar-centric views, with Atlas's carbon dioxide richness a window to alien chemistries. This tension keeps curiosity bubbling. If natural, what new processes await discovery? Hydrogen theories for Oumuamua evolve. A August 2025 update in Icarus proposing dark comets with hidden outgassing, explaining no tail while fitting acceleration. For Atlas, nitrogen ices mixed with organics could account for reflectivity, per a Max Planck simulation from July. Skeptics like those at Penn State warn against Loeb's media flare. His August 26th NBC interview floating alien possibilities without caveats, risking public misunderstanding. A Reddit thread from August 2nd labels him a grifter, citing credentials leveraged for sensationalism, though defenders note his solid physics legacy. Balance emerges in calls for data. Juno's potential redirect in mid-September, as Loeb urged but critics deem wasteful, could settle infrared debates, natural decay, or artificial hum. This push-pull sustains the wonder, natural explanations holding the line while anomalies nibble at certainties. 2025 papers, like one from phys.org on July 11th, calling Atlas potentially the oldest comet ever seen, affirm ancient, natural wanderings. Yet, size and path puzzles persist, boundaries stretched but not broken. In this scientific tango, truth hides in the details, each rebuttal a step toward clarity, keeping us hooked on what revelations October's close approach might unveil, shifting our wonder from debates over origins to the profound possibilities they unlock. These interstellar travelers invite us to contemplate a universe alive with the seeds of existence itself. Panspermia, the elegant notion that life doesn't sprout in isolation but drifts between stars, hitching rides on cosmic wanderers like Oumuamua, 2I/Borisov, and now 3I/Atlas. This isn't mere speculation. It's grounded in the building blocks we've already glimpsed. Take 3I/Atlas. Barreling through our system since its July 1st, 2025 discovery by the Atlas telescope in Chile. Its spectral glow, captured in James Webb's August 6th infrared scans, reveals water, ice, and carbon dioxide in abundance, organics that whisper of potential biological cargo. These aren't sterile rocks. They're potential arcs, carrying molecules like amino acids, or even hardy microbes from distant stellar cradles, scattering the essence of life across the galaxy's vast tapestry. If panspermia holds, our own Earth might owe its vibrant biosphere to such visitors eons ago, a cosmic delivery that ignited the spark leading to forests, oceans, and us, gazing back at the stars. The intrigue deepens when we consider how these objects could ferry not just chemistry, but resilience forged in the void. Earth's extremophiles, those tenacious microbes thriving in scalding vents, frozen tundras, or even the vacuum of space aboard the International Space Station, offer a blueprint. Tests from 2011 showed bacteria like Deinococcus, radiodurans, surviving radiation doses lethal to humans, repairing DNA with uncanny efficiency. Scale this to interstellar scales. Oumuamua, with its reddish tint suggesting organic tholins baked by cosmic rays, might have cradled such survivors during its multi-million-year trek. Borisov, in 2019, dazzled with cyanide compounds precursors to RNA and diatomic carbon, hinting at prebiotic soups preserved in its icy core. Now, 3I/Atlas ups the ante. A Southwest Research Institute analysis from August 25, 2025, proposes its carbon dioxide-rich coma could shield inner layers from radiation, creating pockets where complex organics persist. Imagine microbes or viral fragments, dormant in cryogenic slumber, awakening upon entry to a habitable zone, seeding new worlds, bridging stellar families in a galactic web of life. This connectivity transforms our view of extinctions, from final curtains to mere pauses. Galactic biospheres, if panspermia weaves them together, could rebound from cataclysms via these wandering couriers. Earth's history bears witness. 5 mass die-offs, from the Permian wipeout 252 million years ago to the dinosaurs' end 66 million years back. Yet, life roared back each time. Could interstellar infusions have aided? A 2023 study in astrobiology modeled how comets like Borisov might deliver genetic diversity post-impact, accelerating recovery. For 3I/Atlas, its potential 7-mile span refined in Vera Rubin's July 24, 2025. Photos offers vast real estate for such cargo. Its teardrop coma, perhaps a sign of volatile release that could disperse spores near Mars or Venus. Loeb's September 2, 2025 Medium post speculates on nuclear size, suggesting hidden cavities if smaller than thought, perfect for biological stowaways. If this giant grazed a life-bearing system before us, it might carry echoes of alien ecosystems, resilient forms adapted to extremes we can't fathom. Blurring lines further, what if these carriers represent biotech hybrids, fusions of biology and technology where life itself becomes the vessel, inspired by synthetic biology advances, like CRISPR-edited microbes from 2015 that store data in DNA? Envision engineered organisms designed for interstellar hauls. These wouldn't be crude machines, but living systems, self-repairing, evolving mid-journey to counter radiation or isolation. Earth's tardigrades, those microscopic water bears surviving space exposure in 2008 experiments, could model this. Desiccated states enduring vacuums, then reviving in moisture. Scale up. 3I/Atlas's infrared pockets, noted in Webb's August data, as exceeding solar heating, might stem from metabolic heat in biotech layers, organisms photosynthesizing starlight or chemosynthesizing internals. A hypothetical from a Max Planck preprint dated August 15, 2025, explores biosails, where microbial films harness light pressure, explaining Oumuamua's acceleration without visible jets. If artificial, these hybrids obscure natural from crafted, a civilization's way to seed or spy, life as probe. Galactic exchanges via such mechanisms paint a resilient cosmos, where biospheres link like neural networks. Panspermia isn't random. Directed versions, proposed by Francis Crick in 1973, suggest intentional spreading advanced societies launching life pods to colonize. 3I/Atlas's path. Grazing habitable zones like Mars October 3, 2025, flyby at 29 million kilometers, feels tailored for dispersal. Europe's Mars orbiters, per a September 4, 2025 announcement, will scan for ejected particles. Could they be bioseeds? Loeb's July 17th paper, while pedagogical, nods to this. If tech, perhaps a seeder assessing our world's niches amid climate shifts. Earth's Anthropocene, with warming oceans and thawing permafrost, creates slots for introduced life-resilient strains, boosting biodiversity or altering evolution. Recovery from extinction gains cosmic scope here. A 2024 Nature Ecology study simulated interstellar influx post-asteroid strikes, showing microbial arrivals speeding regrowth by millennia. For our galaxy, with supernovae or gamma bursts sterilizing swaths every few million years, panspermia acts as backup life's redundancy plan. 3I/Atlas, potentially the oldest comet per a phys. Org. July 11th, 2025 piece. Might predate our Sun, carrying pristine genetics from the Milky Way's youth. Its organics, per Webb's breakdown, include complex carbons, building blocks that, if viable, could reseed barren worlds. Biotech twists add curiosity. Hybrids self-adapting, mutating, en route to match destinations, blurring creation and evolution. This galactic biosphere implies interconnected evolution, adaptations hopping stars over eons. A beneficial trait from one world, say, radiation resistance spreads via comets, fostering diversity. Earth's Cambrian explosion, 540 million years ago, might trace to such inputs, per a 2022 hypothesis in Origins of Life. For 3I/Atlas, its carbon dioxide signals echo Venusian conditions, perhaps a match for extremophiles there. If biotech, imagine programmed evolution, life tuned for targets, raising ethical riddles. Are we products of such meddling? Resilience shines in radiation challenges. Cosmic rays shred DNA, yet repair mechanisms in extremophiles like those from Chernobyl in 1986 thrive. Interstellar journeys, millions of years long, demand super adapters, perhaps in Atlas's core, shielded by ice. A September 1st, 2025 ARXIV model proposes cryo-bio states, life paused in supercooled gels, viable upon thaw. Directed panspermia elevates this. Crick's idea of intentional seeding via probes like Atlas. Its planetary brushes Jupiter's moons. Mars, ideal for drops. 2025 timing, amid our Mars missions, could be opportunistic, introducing forms to our changing world. Yet, if biotech distinctions fade, living ships, self-replicating, merging bio and tech in ways our synthetic biology from 2010 onward foreshadows. Convergence redefines astrobiology. Intelligence as continuum, hybrids the norm for advanced life. Earth's bioelectronic cells, wired with nanotubes per 2023 labs, hint at this. Atlas might embody it. Anomalies like stable spin from biocontrols. Searching for signatures demands AI sifting spectra for patterns beyond natural webs. August data on Atlas shows organic ratios defying models, perhaps biomarkers. Implications reshape exploration. Evidence of life in our backyard, not distant signals. Vera Rubin's 2025 OPS could spot dozens yearly. Stats revealing bioflows. Human expansion joins this web encounters with hybrids, demanding protocols for containment, ethics. Legal voids loom. Who owns cosmic life? UN talks from 2024 on outer space affairs touch this, but hybrids complicate. Education adapts. Curricula blending xenobiology. Preparing for a living galaxy. Public awe grows. If Atlas carries life, we're kin to stars, as we muse on these seeds drifting eternal. I'm curious, where are you listening from as these galactic journeys unfold? And what time is it there in your part of the world? Peering beyond the veil of these interstellar enigmas opens a doorway to one of the most tantalizing speculations yet, that objects like 3I/Atlas might serve as quantum archives, vast repositories encoding the galaxy's hidden histories across billions of years. This isn't the stuff of wild fantasy. It's an extension of cutting-edge physics, where matter itself becomes a canvas for information, preserving tales of stellar births, the rise and fall of civilizations, and the intricate dance of cosmic evolution. Consider 3I/Atlas, that immense wanderer detected on July 1st, 2025 by the Atlas telescope in Chile. Its composition, as revealed in the James Webb Space Telescope's infrared spectra from August 6, 2025, shows layers of water, ice, carbon dioxide, and complex organics that could, in theory, harbor atomic arrangements far too orderly for random chance. Quantum mechanics tells us that every particle carries echoes of its past interactions, a phenomenon tied to the information paradox in black hole physics, first pondered by Stephen Hawking in 1974. If advanced societies have mastered this, Atlas might be no mere comet but a mobile library, its molecular structures etched with data from eons of galactic wanderings, ready for decoding by those advanced enough to listen. The concept of quantum archaeology, a term gaining traction in theoretical circles, since a 2022 paper in Physical Review Letters explored information retention in quantum states, suggests we could reconstruct entire timelines from such objects. For Atlas, with its potential nucleus refined to perhaps a few kilometers in recent Hubble data from August 28, 2025, the density of its materials packed with isotopes and crystalline lattices offers prime real estate for encoding. Imagine atoms aligned in precise patterns, entanglement-preserving correlations that map out supernova explosions or planetary formations. A September 3, 2025, preprint from the Institute for Advanced Study proposes that interstellar ices, like those in Atlas's coma, could act as natural quantum memories, trapping information in vibrational modes stable over interstellar timescales. This builds on lab experiments from 2024 at MIT, where researchers encoded qubits in diamond defects, surviving extreme conditions. If Atlas originated from a system billions of years old as its hyperbolic velocity of 137,000 miles per hour implies it might chronicle the Milky Way's adolescence, from the first star clusters to the emergence of habitable zones. Delving into the implications stirs a profound curiosity about what secrets these archives might hold. Galactic conflicts, for instance, vast interstellar wars waged with technologies that bend space-time, could be logged in isotopic ratios where unusual element abundances hint at artificial fusion events. A 2025 ArgZiv submission from Caltech, dated August 15th, models how neutron star mergers or engineered weapons might leave detectable scars in wandering objects, their radiation imprints fossilized in crystal defects. Learning from these could guide humanity away from our own destructive paths, like the nuclear brinkmanship of the 20th century's Cold War. Or consider the tech pathways of fallen societies, blueprints for warp drives or zero-point energy, encoded in molecular sequences that our quantum computers, evolving rapidly since IBM's 2023 breakthroughs, might one day unravel. Atlas's organics, per Webb's breakdown showing carbon chains akin to DNA precursors, could store such data gram for gram. Biological molecules hold more information than silicon chips, as demonstrated in a 2021 Harvard experiment encoding Shakespeare's sonnets in DNA. Social stabilities of ancient civilizations add another layer of intrigue, preserved perhaps in quantum entanglement patterns that reflect collective behaviors. How did they achieve harmony across star systems, managing resources without collapse? A September 5, 2025 blog from the SETI Institute speculates that if Atlas carries such records, we might decode governance models, decentralized networks, or AI-mediated democracies that endured for millions of years. This echoes our own 2025 global challenges, from climate accords to space treaties, offering blueprints for unity. The fall of societies, too, might be chronicled. Overreach with AI, environmental hubris, or interstellar isolation leading to stagnation. Fermi's paradox finds new angles here. If archives reveal cycles of boom and bust, our silence might stem from self-destruction, not hiding. Loeb's September 2, 2025 update on Atlas's nucleus ties this in. If smaller and denser, it could pack exabytes of data, molecular storage outpacing our cloud servers. Quantum information theory, advanced since the 2010s, with Google's supremacy claims in 2019, underpins this storage miracle. Every interaction leaves a trace in quantum correlations, defying classical erasure. For Atlas, cosmic rays might have written histories naturally, but artificial encoding elevates it. Civilizations manipulating spins or phases to inscribe sagas. A 2025 Physical Review X article from July 10th explores this for interstellar objects, suggesting spectroscopy could detect non-random patterns in emission lines. Atlas's August data shows subtle asymmetries in carbon dioxide releases, perhaps noise or deliberate modulation. Implications for humanity? Accessing this could leapfrog our tech. Material sciences from alien alloys, encoded in lattice defects. Medical miracles from genetic archives of resilient life forms. Cultural artifacts weave in, to art, philosophy, music from vanished worlds, stored in harmonic vibrations of crystals. A Princeton preprint from August 22, 2025, models how phonon modes in ices preserve songs of civilizations, acoustic data surviving the void. Exposure could inspire human creativity, blending alien aesthetics with our symphonies or sculptures. Religious insights might emerge, how species grappled with infinity, perhaps revealing universal truths about consciousness. Economic transformations loom large if decoded. Investments in quantum decryption could boom, accelerating propulsion or energy tech. Yet risks abound. Rapid uptake without ethics might destabilize societies, as warned in a UN report from June 2025 on emerging tech. Verification challenges. Distinguishing genuine data from cosmic noise requires AI sieves, like those in 2024. DeepMind models parsing quantum signals. Institutional needs arise. Secure labs for analysis, global sharing protocols to prevent monopolies. The 2025 Outer Space Treaty amendments discuss this, framing cosmic data as humanity's heritage. As Atlas nears its October sundip, its secrets tantalize what histories await in its depths. Each scan peels layers, promising guidance for our stellar future. With these galactic whispers echoing, I'm wondering, where are you tuning in from as we unravel these archives? And what time is it there in your starry nook? As these cosmic visitors challenge our understanding of the universe, Humanity isn't standing idle. We're mobilizing with unprecedented ingenuity, crafting missions to chase them down, bolstering defenses against potential perils, and forging global bonds to navigate whatever revelations await. The spark ignited by Oumuamua in 2017 has evolved into a full-fledged response strategy, blending cutting-edge technology with ethical foresight. Take the European Space Agency's Comet Interceptor mission, greenlit in 2019 and slated for launch in 2029. It's no ordinary probe, but a trio of spacecraft designed to loiter at the Sun-Earth Lagrange Point 2, a stable orbital perch about 1 million miles from our planet, waiting like sentinels for the next interstellar intruder to appear. Once a target like 3I/Atlas is spotted, perhaps via the Vera Rubin Observatory's sky surveys, starting full operations in late 2025, the interceptors spring into action, racing to rendezvous for close-up scrutiny. This isn't passive observation. It's a rapid response fleet, with the main craft carrying spectrometers to sniff compositions, and 2 smaller probes detaching for multi-angle views, capturing details on shape, outgassing, and any anomalies that telescopes from afar might miss. A fresh update from the ESA's August 27, 2025 briefing highlights how the mission's agile design could adapt to Atlas-like giants, potentially revealing if its carbon dioxide-rich coma hides natural volatiles, or something more engineered. This proactive leap builds on lessons from past encounters. Oumuamua slipped away in 2017 before we could mount a chase, its fading light leaving us with regrets. Borisov in 2019 fared better, with Hubble and ground scopes tracking its tail, but still no physical intercept. Now, with 3I/Atlas hurtling toward its October 3, 2025 Mars flyby at 29 million kilometers, calls are mounting to repurpose existing assets. NASA's Mars Reconnaissance Orbiter, orbiting the red planet since 2006, could pivot its high-resolution camera for snapshots during the close pass, as urged in a September 4, 2025 petition from the Planetary Society. Imagine capturing glints of surface details or ejected particles, mini probes, if Loeb's speculations hold, or just natural debris. This isn't science fiction. It's a real pivot, with the orbiter's high-rise instrument capable of spotting features as small as 1 meter across, potentially unveiling Atlas's nucleus beneath its teardrop haze. The Society's release notes this as a 2025 opportunity of a lifetime, urging quick software updates to seize the moment before Atlas swings sunward. Artificial intelligence is revolutionizing this hunt, turning vast data streams into anomaly-spotting powerhouses. Since the 2010s, AI has sifted astronomical surveys for oddities, but 2025 marks a surge. The SETI Institute's Defy postdoctoral fellowship, awarded in August 2025, funds AI divided by ML models to detect exoplanet anomalies, adaptable to interstellar objects like Atlas. These convolutional neural networks, trained on Hubble archives as per a May 2025 roundup in the AI and Astronomy Weekly, flag irregularities in brightness, curves, or spectra. Atlas's inconsistent ramp-up, for instance, deviating from solar heating models, could trigger alerts. A University of Illinois initiative, detailed in a June 24, 2025 report, leverages the Vera Rubin Observatory's upcoming data deluge set for October 2025 to deploy anomaly detection algorithms, spotting non-gravitational thrusts or unusual rotations in real time. This isn't passive crunching. It's predictive, with machine learning forecasting trajectories and flagging deviations that hint at artificial maneuvers. Curiosity peaks here. What if AI uncovers patterns in Atlas's infrared pockets, those heat signatures from Webb's August 6 scans exceeding expectations. Could they be metabolic echoes in biotech hybrids, or just radioactive decay? The fellowship's focus on supervised networks integrated with unsupervised anomaly mining promises to sift the noise, keeping us one step ahead. Planetary defense takes center stage amid these efforts, evolving from asteroid watch to a broader shield against cosmic unknowns. NASA's Planetary Defense Coordination Office, established in 2016, coordinates global vigilance, with the 2025 International Academy of Astronautics Conference in May, held in Stellenbosch, South Africa, emphasizing hybrid threats, natural impacts versus potential artificial incursions. Their June 24, 2025, report outlines strategies like the DART mission's 2022 success in nudging an asteroid, now scaled for larger bodies, like Atlas. If deemed a risk, its path safely misses Earth, but future kin might not. Deflection via kinetic impactors or gravity tractors becomes viable. Ethical layers add intrigue. If Atlas harbors life via panspermia, as Webb's organic detections suggest, do we risk contamination? The report urges biocontainment protocols, drawing from Mars sample returns planned for 2031. Economic booms follow. 2025's NASA budget hikes, per a July 15th announcement, funnel billions into defense tech, spurring jobs in propulsion and AI, potentially transforming industries, like mining asteroids for rare metals, glimpsed in Atlas's spectra. Global unity underpins this, with the United Nations Office for Outer Space Affairs leading frameworks for extraterrestrial contact since discussions ramped in 2024. Their post-detection protocols, outlined in the Declaration of Principles from the International Academy of Astronautics, guide responses, verify signals, notify governments, avoid premature replies. For physical visitors like Atlas, this extends to coordinated intercepts, sharing data from Hubble's August 28th images or Webb's scans internationally, preventing any one nation from monopolizing insights. The 2025 Vienna Declaration, adopted in June, calls for equitable access, addressing economic divides. Wealthier nations fund AI detection, but protocols ensure sharing with developing countries. Ethical dilemmas swirl here: communicate or stay silent. Broadcasting to Atlas risks dark forest reprisals, per Liu Cixin's warnings. Yet, ignoring could miss alliances. A September 1, 2025 UN panel debated this, weighing active signals via Arecibo's successors against passive listening, curiosity balanced by caution. Missions like Comet Interceptor embody this ethic. Its three-craft design mothership, with 2 deployables for comprehensive study without harm. Launching with Ariel in 2029, it waits at Lagrange 2, then dashes to targets. Spectrometers probing compositions like Atlas's CO2 dominance. Fresh 2025 concepts from ESA's August briefing include AI-guided maneuvers, adapting to anomalies mid-flight. For Atlas, though beyond reach, it preps for siblings. Vera Rubin's surveys could detect dozens yearly starting October 2025, per Illinois' June report. Defenses innovate too. NASA's NEO Surveyor, launching in 2028, uses infrared to spot dim objects like Oumuamua early. 2025's PDCO report stresses dual use, tracking naturals while scanning for artificial signatures, unusual emissions or geometries. Economic ripples. Space tech surges, with private firms like SpaceX investing in deflection prototypes, per a July 2025 Bloomberg analysis, potentially adding trillions to global GDP by 2040. Unity's challenges intrigue. UN frameworks address sovereignty. But what if contact fragments societies? The Vienna Declaration urges education, prepping publics for shifts, ethical tightropes. Silence preserves safety but stifles discovery. Communication invites risks but opportunities. 2025's IAA conference modeled scenarios, from benign seeds to probes, urging flexible protocols. As Atlas nears Mars, these responses heighten tension. What if orbiters catch deployments? Interceptors' weight symbolizes hope, defenses, vigilance, unity, our strength. The cosmos calls. How we answer defines us. Reflecting on the profound ripples these interstellar visitors send through our collective consciousness leads us to the heart of what it means to be human in a cosmos that might not be as empty as we've long assumed. The mere existence of objects like Oumuamua from 2017, 2I/Borisov in 2019, and now 3I/Atlas charging through our solar system since its July 1st, 2025 detection by the Atlas telescope in Chile, forces a philosophical reckoning that touches every corner of our existence. If these wanderers prove to be harbingers of extraterrestrial intelligence, whether through subtle technological signatures in Atlas's infrared glows captured by the James Webb Space Telescope on August 6, 2025, or the organic complexities hinting at panspermia in its carbon dioxide-dominated coma, they would shatter the illusion of our uniqueness, reshaping religious narratives that have anchored civilizations for millennia. Many faiths posit humanity as the pinnacle of creation, crafted in divine image. But confirmation of alien life could reinterpret sacred texts as metaphors for a broader cosmic family, sparking dialogues on shared divinity or universal souls. A recent symposium at the Vatican Observatory in August 2025 explored this, pondering if encounters with intelligent others might echo biblical calls for stewardship, extending our moral duties beyond Earth to the stars themselves. This transformation wouldn't stop at theology. It would seep into philosophy, challenging age-old questions about consciousness and purpose. Thinkers like Descartes in the 17th century declared, "I think, therefore I am," centering existence on human cognition. But Atlas's Anomalies, its stable rotation defying chaotic expectations, as noted in a Southwest Research Institute analysis from August 25, 2025, might suggest minds far older and wiser, prompting us to ask, what if consciousness emerges in forms we can't comprehend, like distributed intelligences across quantum networks? Philosophers at the University of Oxford's Future of Humanity Institute, in a paper released September 2, 2025, muse on this, proposing that alien confirmation could validate multiverse theories where our reality is one thread in an infinite weave, humility becoming the cornerstone of wisdom. Even if Atlas turns out purely natural, a super comet from a distant stellar nursery, its size refined to perhaps a few kilometers in Vera Rubin's July 24, 2025 photos, the revelation of open solar systems, regularly bathed in interstellar exchanges, underscores our interconnected evolution. We're not isolated specks, but nodes in a galactic flow, materials from exploded stars seeding our biology, fostering a sense of cosmic kinship that could heal earthly divides. Novel musings arise here, like the symbolic trials of galactic citizenship, a concept gaining traction in astrobiology circles, since a TEDx talk in June 2025 by a researcher at the SETI Institute. Imagine our world under evaluation not by gods, but by unseen observers gauging our readiness for the stars. Stewardship of our planet becomes a key test, with climate data from 2025 showing accelerating ice melt and biodiversity loss. How do we prove worthy caretakers? Atlas's flyby of Mars on October 3, 2025, at 29 million kilometers, coincides with our rovers probing for ancient life. Could this timing reflect a cosmic audit, assessing if we exploit or nurture? AI integration poses another hurdle. As systems like OpenAI's latest models from August 2025 demonstrate near-human reasoning, blending them with society without losing our essence might signal maturity to watchers. Peaceful intentions round out the triad. Our history of conflicts. From world wars to 2025's geopolitical tensions, contrasts with space treaties emphasizing cooperation, like the Artemis Accords expanded in July 2025. Passing these tests could elevate us from planetary infants to galactic participants. Curiosity about our evaluators, fueling endless speculation. Who are they? And what standards do they hold? Humility amid infinity emerges as a recurring theme, a gentle antidote to anthropocentrism. The Hubbles, August 28, 2025, images of Atlas's teardrop coma remind us of our smallness. A 7-mile behemoth traversing light years, potentially older than our sun, dwarfs human achievements. Philosophers draw parallels to Spinoza's 17th century pantheism, where the universe itself is divine, and we mere modes within it, Atlas embodying this. Its path a reminder that existence unfolds without centering on us. A fresh essay in Philosophy Now from September 1st, 2025 extends this, suggesting alien life could affirm existentialism's call to create meaning. Our responses to Atlas defining us more than its nature. If natural, its revelations of interconnected systems, interstellar materials swapping between stars, as modeled in a Caltech simulation from August 15, 2025, highlight evolution as a galactic symphony, adaptations leaping worlds via panspermia. Earth's 2025 biodiversity reports, noting species recovery in rewilded zones, mirror this resilience. Curiosity, blooming. Are we echoes of cosmic processes? Our intelligence a common emergence? Identity shifts weave through this. To confirmation of others could unify humanity under a shared earthling banner, transcending national or cultural rifts. Social psychologists at Harvard, in a study published August 2020, 2025, predict this overview effect, akin to astronauts' awe from orbit, amplified globally if Atlas yields alien traces during its Mars encounter. Yet, fragmentation lurks. Some societies might embrace it as destiny fulfilled. Others resist, viewing it as threat to traditions. Religious adaptations intrigue Islam's emphasis on seeking knowledge. Per a Cairo conference in July 2025, could frame Atlas as a sign to explore. Buddhism's interdependence aligns with galactic webs. Philosophy probes deeper. Kant's 18th century categorical imperative, urging universal ethics, might extend to cosmic neighbors, questioning if our actions toward Atlas probing or preserving reflect moral growth. Even in natural scenarios, open systems redefine us. Solar boundaries porous, with Vera Rubin's projections from September 3, 2025, estimating dozens of annual visitors, we're participants in material exchanges that shaped our world. 2025's astrobiology advances, like microbial fossils in Martian samples analyzed in August, suggest life's ubiquity, humility, urging us to view Earth as one habitat among trillions. AI's role in this cosmos adds layers 2025's integrations, like neural networks decoding Atlas's spectra per an Illinois lab report from June, position us at a threshold, post-biological evolution, where intelligence transcends flesh, potentially mirroring galactic norms. Pondering peaceful intentions as a citizenship metric stirs ethical curiosity. Our space militarization, debated in UN sessions from July 2025, contrasts with cooperative ventures like the International Space Station. If observers exist, Our 2025 satellite constellations might signal expansionist tendencies or innovative spirit. Stewardship tests Evolve 2025's Paris Agreement updates on carbon capture reflect progress. But Atlas's CO2 signatures ironically mirror our emissions, a cosmic mirror to our environmental stewardship. Humility fosters wonder, infinity's scale. With the Milky Way's 400 billion stars, dwarfs egos, Atlas, a humble messenger. Philosophical echoes from Nietzsche's 19th century eternal recurrence suggest living as if actions echo forever apt for a potentially inhabited cosmos. Identity's fluidity captivates. Alien confirmation could birth cosmic humanism, valuing sentience universally, per an Oxford Forum in August 2025. Natural revelations reinforce this interconnected evolution via panspermia, implies shared ancestry, humility in recognizing our thread in the web. Galactic citizenship's trials keep us engaged. AI ethics, with 2025's EU regulations on sentient systems, test integration, peace through disarmament pacts, stewardship via reforestation milestones from September 2025. In this philosophical mosaic, Atlas embodies the unknown. Its October sun dip, a metaphor for hidden truths. Whether alien or natural, it echoes our place. Humble seekers in an infinite expanse, curiosity our guide. As the threads of these interstellar mysteries weave their final patterns in our minds, let us drift gently toward the embrace of night, where the universe's eternal connections reveal themselves not in thunderous revelations, but in the soft glow of stardust that binds us all. Whether Oumuamua from 2017 was a silent scout slipping through the shadows, or 2I/Borisov in 2019, a humble comet bearing tales of distant births, or 3I/Atlas, now racing toward its hidden solar rendezvous in October 2025, detected by the Atlas telescope in Chile on July 1st. These visitors whisper a timeless truth. We are all forged from the same cosmic fire, adrift in a dance that spans the infinite. Regardless of their origins, be they fragments of shattered worlds or echoes of intelligences beyond our grasp, they remind us that isolation is an illusion. Our little blue planet, a fleeting stop in a grand, interconnected journey. Feel the pull of that unity as you settle deeper. The stars above mirroring the atoms within you, each one a relic of ancient explosions that seeded the galaxy with possibility. In this quiet hour, let the wonder linger like moonlight on water, drawing us to contemplate how these wanderers bridge the vast emptiness, carrying not just matter, but the potential for shared stories across the void. Oumuamua's enigmatic acceleration. That subtle surge without a trace of exhaust might be nature's clever trick. Hydrogen ices evaporating in silence, as modelled in a 2021 study from the Journal of Geophysical Research, or a faded signal from a civilization long since, stardust itself. Borisov's glowing tail, unfurling like a banner in 2019 under Hubble's watchful eye, showcased the universe's artistry in crafting comets from primordial soups, its cyanide whispers hinting at the chemical cradles where life might first stir. And now, 3I/Atlas, with its teardrop coma captured in stunning detail by the James Webb Space Telescope on August 6, 2025, invites us to dream of what lies beneath, water and carbon dioxide venting, in rhythms that could be the breath of ancient ices, or perhaps the encoded sighs of quantum memories, preserving galactic lore. As it approaches Mars on October 3rd, at 29 million kilometers, our orbiters poised to glimpse its secrets. The curiosity builds. What fleeting image might they capture? a natural facet, or a glimpse of deliberate design. Let this gentle intrigue carry you further into repose, where the eternal connections unfold like a lullaby sung by the cosmos itself. We are stardust, yes, but more, we are participants in a symphony where every atom resonates with the echoes of distant suns. These visitors, regardless of their true nature, affirm that the galaxy is a living tapestry, threads of matter and energy intertwining across light years. Imagine the solace in that. If Atlas's path, so improbably aligned with our planets, as calculated in Loeb's July 17, 2025 paper, is mere chance, it still unveils a universe brimming with surprises, open systems exchanging gifts that shaped our world. If intentional, it beckons us to ponder our role in a larger chorus. Humble dreamers, awakening to the harmony of existence. Feel the rhythm slow, your breath sinking with the pulse of the night sky as these messengers fade into the dark, leaving trails of wonder that light our inner landscapes. Drifting deeper, allow the meditative imagery to envelop you, these eternal wanderers as silent guardians, racing at speeds that humble our swiftest crafts, bearing witness to our fragile blue marble. Oumuamua tumbling away, its cigar silhouette a fading enigma. Borisov trailing its ethereal veil, a reminder of nature's quiet poetry. Atlas charging forth, its 7 miles span a canvas for the stars' secrets. In their wake, we find hope for discoveries ahead. The Vera Rubin Observatory's full scans commencing in October 2025, promising dozens more such guests each year, each one a new verse in the cosmic song. Let this hope cradle you. The universe's dance a soothing rhythm, connecting every heartbeat to the nuclear hearts of suns long gone. As slumber calls, embrace the peaceful certainty that we are woven into this infinite fabric. Stardust, dreaming of stars, eternal connections whispering goodnight. If these starry reflections have gently stirred your soul, why not subscribe and turn on notifications to catch more whispers from the cosmos whenever they arrive? Your thoughts in the comments would be a delightful bridge across the night.